Hello everyone and welcome back to Newton's Academy past paper review for grade 12. Today we will be attempting yet another question on Euclidean geometry, and that will be question 9, which is involving similarity. Getting right into the question gives us a diagram and tells us that PSW, which is that line, and WT, which is this line, are tangents to the circle RST at points S and T respectively. Line PT is drawn and intersects the circle at point R. RS and ST are joined, so RS, ST are joined, and RT equals TS. Let S1 equal X and T2 equal Y. And they've drawn this all in a diagram for us. The first question asks, name with reasons 3 angles each equal to Y. And we see Y is an angle here going from a tangent to a chord. So that should be our first indication that majority of these angles that we are naming should come from the proof tan chord, especially since they told us that tangents are present in this diagram. We already need to be thinking of theorem 7, 8, and 9, which involve our tangents. So looking at this, we can see that this angle here is from the tangent to this chord and therefore will be equal to R2 due to the theorem tan chord. So let us go ahead and write that down. So question 9.1, that will be R2 equals Y, and the reason will be tan chord. Okay, just a quick tip on how to identify which angles are equal when using the tan chord theorem. When drawing a line, an arrow just like this from your tangent to your chord, you identify this line here, and the angle directly opposite that chord is the angle that will be equal to the angle that was initially present from the tangent to the chord. So therefore T2, which is Y, will be equal to R2. So you simply draw an arrow from the tangent to this chord, and the angle opposite that chord will equal to that angle there. So R2 is equal to Y tan chord. Okay, then we know that ST and RT are equal, so therefore S2 and R2 are equal because of angles of opposite equal sides. So S2, let me just change the color, S2 will be equal to R2, which equals Y, and the reason will be angles opposite equal sides. And they already gave us that those two sides are equal. Okay, and then our last angle, we see that, okay, obviously angle T1, we cannot prove that that is Y because it forms tan chord with this. However, angle S3 also forms tan chord theorem with angle R2. So angle S3 will form tan chord with R2, so therefore S3, angle S3 will equal to angle R2, which equals to Y, and the reason there will be tan chord once again. So S3 equals to angle R2, and the reason there will be tan chord theorem. Okay, moving on to question 9.2. It asks us to prove that triangle PRS, which is that triangle there, and PST, which is that triangle there, it's asking us to prove that those two are similar. So we obviously are not given the lengths of any sides, therefore we will have to prove similarity by proving that the 3 interior angles of the triangles are equal. So a quick tip when proving similarity, when the question words a similarity proof like this, it often matches the angles that are equal to each other. So angle P equals angle P, angle R in this triangle will equal angle S there, and angle S in this first triangle will equal to angle T. So we already see that that is true because angle P is common in both triangles. Angle P is the same angle in both triangles, so that's our first statement, that angle P is common. So we only have to prove 2 more angles. PRS, okay, and PST, those are supposedly equal, but there's no distinct way to prove that. So let us look at the next angle if there's an easier way. Angle PSR and angle PTS. Yes, those are equal because of tan chord theorem. So angle S1 and angle T1 are equal. Angle S1 is equal to angle T1, and the reason there will be tan chord theorem, and that is equal to x. So those two are equal. And then once you've proven in any two triangles that two angles are equal, the third angle is automatically equal. So angle PRS and angle PST. So angle PRS is equal to angle PST, and the reason there would be sum of angles in a triangle. So when proving similarity, you essentially only need to find two angles that are equal, because once two angles are equal, then the third angle of the triangle is automatically equal. Okay, and then therefore we can conclude that triangle, therefore, okay, let me just erase this line. Right, sorry about that. So therefore we can conclude that triangle PRS is similar to triangle PST, and our reason there will be angle, 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 because we have proved that all three angles are equal. Okay. On to our last question, 9.3. They're asking us to prove that PS multiplied by RT is equal to RS multiplied by PT. Now, a lot of students, when they see a question like this, especially involving products of sides, they start to stress and they are not sure what to do and they get stuck very easily. However, remember that all questions are a build-up of each other most of the time. Each question is a build-up of each other. So the fact that we had to prove similarity here tells us that we're going to use similarity in this question, or rather the similar triangles that we have proved in the previous question, to prove this statement here. And how do we do that? Well, we know that because the triangles are similar, their sides are in proportion, so we need to choose two pairs of sides that are in proportion to determine this expression. So we see that PS is in this expression, and the corresponding side there is PT, so we have PS and PT, and then we have RS, which is there, and the corresponding side is ST. But we see here we have RT, but that's not to worry because we know that ST and RT are equal because of the question has gave that to us. So we can write the fractions using PS, PT, RS, and RT because of similar triangles. So we write those as fractions. So question 9.3, because the triangles are similar and the sides are corresponding sides are in proportion, we can say that PS over PT is equal to RS over S over ST over ST, and our reason there is similar triangles. Okay, well, the triangles are similar. So given the fact that we've proved that triangles are similar, this ratio holds true. And where do we get that ratio from? Once again, that will be from the two triangles. We pair them up. So P and S goes with P and T, and then R and S goes with S and T. So PS over PT will be equal to RS all over ST. Okay. And furthermore, we said that the question gave us ST being equal to RT. So that is given. Therefore, we can substitute where we see ST, we can substitute RT. So we have PS all over PT equals RS all over RT. Then we simply cross multiply. So we get PS multiplied by RT is equal to RS multiplied by PT. And looking at what the question asked us to solve, we can see that we have successfully solved this expression. PS times RT equals to RS multiplied by PT. And that brings us to the end of this question on Euclidean geometry. So we have successfully proved that that is true. PS times RT equals RS times PT. Thank you for watching.